Hey, so I got a question about this partial fraction problem. So this one is two repeated linear roots. And these might feel like squares because they're squares, but this is, remember, it's a repeated linear because if we can factor it and write it as a chunk squared, then we can write it as an x squared, x plus 1, x plus 1 squared. I changed the order just because of preference. So here I'm just saying if I have an x squared down here, I could have a term that's an x. I have to have a term that's an x squared. Likewise, if I have an x plus 1 squared, I could have an x plus 1 and an x plus 1 squared. So these are all repeated linears, so I'm just setting these up as constants, a, b, c, d. Once I did that, I didn't have room, but what I did was I took my LCD and I multiplied both sides, and that's where all this stuff cancels. So here one of the x's canceled, the x squareds, an x plus 1, and both x plus 1s. So that gets us that working equation. From here, we have a couple of different ways we could go. We could do method 1 or method 2. Again, for me, I usually, if there's any zeros to use, that is generally my preference. In this case, we have 4 things defined, A, B, C, D, but we have 2 zeros, so we might as well use those and get what we can. So first thing I do is I'll let x equal -1, and then I toss that in here. So -1 cubed would make a -3 squared, +4, -1, plus 1, 1. And then on this side, the -1's going to kill off anything with an x plus 1. So that's gone, and that's gone. So it just left d x squared down here. And then x was -1 again, so plugging that in, there's our d equals 1. Do the exact same thing with the 0, and then you get -1 equals everything with an x drops out, so we just have that b term. And right there I got b equals -1. So from there, what I did was, since I know d now, I put that in here, and I know b is -1, so I put that in there. And that's all I'm showing on that line. So from this line, I now have kind of 2 choices as to where I can go. And I'm not sure if the other one would have sucked less. I think they both kind of suck on this one. I could have, at this point, taken and made up, so I've used x equals -1 and x equals 0. I could plug in, and notice I do have the b and the d in there. So I could now plug in, make something up, x equals 1, because it's an easy number, and I would get an equation in a and c. And then I can make up something else, like x equals 2, and plug that in and kind of grind out all that math and get it down to another equation that will be a number and then something in terms of a and c. And then I would have a system of 2 equations with 2 unknowns that I could solve. So that would involve some evaluating, plugging in numbers and evaluating and cleaning that up. I chose to clean it up algebraically. You may prefer the numerical value. For me, I prefer the algebraic value, but it's just I make fewer errors this way. So what I did was I switched over to method 2 at this point with that -1 and 1 in there for the d and the b. And I expanded out these squares and I distributed that. So here's that expanded, here's that expanded, and then I distributed those 2. Then I ran my ax through this, my -1 through there, and that got me to this line. So just kind of cleaning up the algebra. I had a couple of terms cancel there. And then notice I have terms involving a's and c's, and I have terms that aren't. So for the ones that aren't, I'm moving those over here to get them with my other algebraic terms. So that got all this combined. And now on this side, I only have my terms that had an unknown in them. So put my cube terms together here, factor out the x cubed, put my squared terms together there, factor out the x squared, and there's my linear term. From here, I am matching a plus c has to be 3, so we got that there. 2a plus c, that's in front of the x squared. Whoops, that should be a 4x squared right there. Apologies, I dropped it right here. So that would be 2a plus c makes 4. And then this one's nice, x squared equals 2x, or a squared equals 2x, so a has got to equal 2. Knowing that, I plugged it in here and got my c equals 1. And there's my solution. Again, I could have got that same thing by making up 2 more numbers and plugging them in. That might have actually been easier math. Again, it's not that great either direction, so that's the one I happen to pick.